Hey, what's going on, guys? Let's do this problem right here. This question is asking find the radius and intervals of convergence of this power series. Let's see how we can find it. The first thing we have to do is we have to take the ratio test. Ratio test is going to be like this: limit n approaches infinity, absolute value an plus 1 over an, right? So this is going to be the ratio test. Now an plus 1 is basically that we just add one more to n wherever we have n, right? So here we have x power n, that's going to be limit n approaches infinity, x power n plus 1, and then we have 5 power n plus 1, and in the denominator we have n in the here too, right? So that's going to be n plus 1, and in the power also we have n, so this is going to be again n plus 1, and this is what we are going to have. Now we have to divide this one by the original series, that's an. It's same as multiplying by its reciprocal, so we can multiply this one by n power n over x power n dot 5n is multiplication. So if you divide this one by this one, you will get same results because it's going to flip around, right? Now let's cancel everything we can cancel, and if you notice we have x power n plus 1 it's basically x power n times x power 1, right? So if you cancel this one, x power 1 will remain. So here we can cancel this one, so x power 1 will remain, and this one is same as this expansion, like 5 power n times 5 power 1. So if you cancel this one, it's going to be 5 power 1 is going to remain, and n power n plus 1 n plus 1 remaining. Now let's go ahead and simplify this one and see what we get. Now let's continue this one right here, right? Limit n approaches infinity, and then we have 5x in here. Let's put one over here, and we have n power n, and in the denominator we have n plus 1 power n plus 1. Instead of writing n plus 1 power n plus 1, we can do one thing right here. We can write n plus 1 power n times 1 over n plus 1 power 1, right? If you multiply, the power will add. So you can also separate like this. Now since we are not doing anything for this 5x, we can move this 5x to the front, because this is only dealing with n, right? N approaches infinity, so we only substitute n right here. Now we can move the 5x to the front. This is going to be 5x absolute value, limit n approaches infinity, and here we are going to have n power n over n plus 1 power n, right? Or you can directly write it all together like n plus 1 all together power n, right? You can also write like this, because since both of them have power n, and then we have 1 over n plus 1. And you know that if you take the limit for this one, this is going to be 0, because if you apply limit 1 over infinity, that's going to be 0. But this part is really a little bit unsure. But if you remember this part, you can also memorize this part, because you will see mostly these kind of patterns. This is basically 1 over e. And if you are unsure about that, and if you remember e is this pattern, 1 over 1 plus 1 over n. If you remember e pattern, you can derive e pattern from this one. Like, let's take this one alone. So here we have limit n approaches infinity, and here to get the e pattern, what you can do is you can simply put 1 here, n plus 1, and bring this n down to this one. Like dividing this one by this n is same as like multiplying this one, because this is going to flip around and go. So this is same as this expression, and here you can see we will get 1 over 1 plus 1 over n, right? And that is same as this one. This is e, and you can notice that this is 1 over e, right? Or you can use L'Hopital rule. Since this is infinity over infinity, you can use L'Hopital rule to derive this one. So everything gives the same answer. Now we have 1 over e 0. So the limit is going to be basically 0, because here we are going to have 5x times 1 over e times 0, right? So if you combine these two, this is going to be 0. So this is 5x times 0 is less than 1, right? And no matter what value you plug for x value, you will always get 0. So anything is possible. So the intervals of convergence is going to be negative infinity, all the real numbers, negative infinity to positive infinity, right? So that's going to be the intervals of convergence. Now the radians of convergence is going to be absolute value of this one. That's going to be r is equal to infinity, right? So this is our radius of convergence, and this is our intervals of convergence, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.